welcome back to another installment, another section of Chapter 1. This is on square roots. In this one we'll learn about approximating and estimating and when it's appropriate to do so, as well as simplifying and adding and subtracting. We're starting to get into a little bit of math here, and this is again something that you've most likely seen and done in the past, but may or may not remember all the different ins and outs of it. So we have a couple learning targets today. The first one, I can estimate square roots. And the second one, I can add, subtract, add, simplify, multiply, and divide square roots. First piece, square roots, we're going to look at the exact answer versus the approximate answer. The exact answer to a square root will most likely still have a square root in it. Unless it is an actual integer, it will probably be something like root 2, as opposed to the approximate answer, which is 1.4, 1.41, 1.414. You can keep going as many decimals as you want. That is still an approximate answer. Sometimes we have things like 3 root 5. That would be an exact answer. The approximate would be, again, the decimal. When are approximate answers appropriate to use? If you're measuring something, or if you're told to round or estimate to the nearest tenth, hundredth, things like that. Measuring use approximates because your tape measure doesn't have roots on it, and how accurate is your measurement anyway? At some point, the decimals no longer matter. When do you use exact answers? All the time, except when measuring or if you're told to round or estimate. If you get a question and the answer is root 2 and you give me 1.414, you will lose points unless you're told to round. So how do you estimate? If we have a root, say root 12, and we want to estimate it, we want to think, well, what two numbers is this going to be between? What number less than 12 can I take the root of? That would be 9. And the number bigger than 12? 16. Well, the square root of 9 is 3, the square root of 16 is 4, so the square root of 12 is going to be in between 3 and 4. Those numbers all look like 3 point something. We just need to think, well, 3 point what? About how far in between these is 12? In between 9 and 16. It's about halfway in between 9 and 16, so about 3.5-ish would be a good estimate. Now, when you're estimating, you're not estimating to answer a question on a test or something like that. You're estimating to make sure something horrible didn't go on in the calculation. If you were doing the square root of 12 and you end up with 144, that is not anywhere near 3.5. You want to know about what it's supposed to be at. What happened if you got 144 when you did a square root of 12? Well, instead of square rooting, you accidentally squared it. What if you square rooted it and got 11? Well, this would be a typing error probably, because the square root of 121 is 11, so you may have had an extra digit in there somewhere. And so knowing about what you're supposed to get is a good thing to make sure that something horrible doesn't happen in your problem. So try estimating this one, square root of 60. You can pause the video if you want, or you might almost be there. Do you have an idea? Well, what numbers are on either side of it that you can square root? We have 49 and 64, which will put the square root of 60 in between 7 and 8. And then looking at 49, 64, 60 is a lot closer to 64. So 7.8, 7.7. I think it's about 7.745 or something like that. But we knew it should be 7.7, 7.8, somewhere in that area. So that's what the estimate is about. All right, and simplifying. When we're simplifying, we use a couple properties, whether we really think we're using them or not. The first one's the product property. The product property says if you have the square root of two things multiplied together, That's the same thing as multiplying the square roots of the individual things. And so, how would this work? Let's go back to root 12. 12 is 4 times 3. So if I have the square root of 4 times 3, that means I have the square root of 4 times the square root of 3. I know what the square root of 4 is. The square root of 4 is 2. So we have 2 root 3. And that would be simplified. That's using the product property very, very directly. A lot of times, though, you're not going to look at a number and think, oh, that's this perfect square times this other number. It just doesn't work out that way. And so I'll show you another way of kind of getting there without having to be able to factor it very specifically like that. The other property that we'll use is the quotient property, which is very similar to the product property, except uses division. If you have something a divided by b, there should be a line there, that's the square root of a divided by the square root of b. So if you have a fraction underneath the square root, you can deal with the top and the bottom completely separate from each other. And so that simplifies things quite a bit. So let's look to see how we can simplify square roots without having to factor out a perfect square right away. Let's look at the square root of 162. That one's a lot harder to see a perfect square in. It's there, and we'll actually find it without trying. We're going to make a factor tree. So what times what equals 162? It's even, so I know that 2 times something, so 2 times 81 equals 162. Well, 81's a perfect square, so that'll be 9 root 2. But let's pretend that we didn't see it was 2 right away, and let's keep factoring. So 2 is already prime. 81, that's 9 times 9. And 9 is 3 times 3. 9 is 3 times 3. And so now we have our prime factorizations. Now what we're going to do is we're going to look for groups of 2. Because a square root is like a prison. It takes 2 to get out. So we have a group of 3's, and we have another group of 3's. So this group of 3's makes a break for it. One of them makes it to the outside. The other one gets shot and dies. This group of 3 also makes a break for it. One of them makes it to the outside. The other one gets shot and dies. And then left over inside the root still, we have this lonely 2. He didn't have anyone to make a break for it with, so it's still inside the root. And what do we do with the stuff on the outside of the root? It'll just multiply together. So 3 times 3 is 9 root 2, which is what we saw when we were up here. The square root of 81 is 9, so that'll be 9 root 2. Looking at one with a fraction, square root of 50 over 9. We can split this up to be the square root of 50 divided by the square root of 9. We know the square root of 9 is 3, so we don't really have to worry about the bottom in this case. But the square root of 50 is 5 times 10, and 10 is 5 times 2. So we have our group of 5's. They make a break for it. One makes it out. The other gets shot and dies. So we have 5 on the outside and a 2 left on the inside, all over that 3 because the square root of 9 was 3. So here's an example where we could have gone 50 is 2 times 25, and we would have had that perfect square. But if you didn't see that, we still get to the same answer because every number has a unique prime factorization. So it'll always be the same. And then rationalizing the denominator. Sometimes after we simplify, we have a square root in the denominator still. Well, fractions are one thing, and if you have to have an irrational number in a fraction, it just has to happen. But we don't want them in the denominator. If we have an irrational number, we want it in the numerator. So if you simplify something and you end up with a square root in the denominator, we need to do what's called rationalizing the denominator. We need to make it a rational number. So how could we get the square root of 3 to be a rational number? Well, we can multiply by itself because the square root of 3 times the square root of 3 is the square root of 9, which is just 3. Well, can we go around multiplying denominators by whatever we feel like it, all willy-nilly like? No, we can't. If we multiply the bottom by the square root of 3, we have to do the exact same thing to the top. Multiply by the square root of 3. And so 2 times the square root of 3 is just 2 times the square root of 3. Over root 3 times root 3, we already saw was 3. When you multiply numbers, when you multiply roots, the outsides can multiply together, the insides can multiply together, but you don't multiply the outsides with the insides. And one of the biggest mistakes here is people will do root 3 times root 3, well, that goes away. That doesn't go away. The root goes away, and we're left with just 3. So that's simplifying. The last thing we have is adding and subtracting roots. If we're adding and subtracting roots, we treat the root basically just like a variable. If I have 4 root 3's minus 9 root 3's, 4 minus 9 is negative 5 root 3's. Notice that the root does not change when we're adding and subtracting, just like with variables. 4x minus 9x is negative 5x. The difference between square roots and variables is that we can simplify square roots. If these were just x and y, we wouldn't be able to do anything. But being square roots, we can simplify them and see they might have the same root. And so this first one, we've got a 48. So 48 is going to be 2 times 24. Well, 24, I can get a little bit. That's a 4 times 6. And the 4 is 2 times 2. And the 6 is 2 times 3. So we have some pairs here. We've got a pair of 2's, another pair of 2's. So this pair of 2's makes a break for it. We get 1, then we get shot. This one, we get another 1. So there's 2 2's. And then this other one that was already on the outside, so we have 2 times 2 times 2. There's 3 2's, which will give us 8 root 3. So we have 8 with the 3 left over inside. Then minus 2 times square root of 12. We just did the square root of 12. It was 2 root 3, right? Because 12 is 4 times 3. Square root of 4 is 2, so we get 2 root 3. Times this other 2 is going to be 4 root 3. So you have 8 root 3's minus 4 root 3's. Hey, look, the roots are the same now. We can subtract them to get 8 minus 4 is 4 root 3. If you simplified, and this would say like 8 root 5 minus 4 root 3, you'd be done. You wouldn't be able to do anything. And you would just leave it as 8 root 5 minus 4 root 3. And so that's adding and subtracting roots. We're actually getting into some math now, and we'll continue doing actual math throughout at least most of the rest of the chapter, and then a lot more in the next chapter and pretty much every chapter after that, with little bits of vocab here and there. Anyway, I will see you later.